Okay, today we're doing the last actual section of the unit. Our unit test will be 4 days and 3 or 4 days. With you guys, I'll just tell you now, it's Friday. Okay, so we're going to learn and practice the rest of the week. Our last topic, besides solving word problems, which is involved in today's lesson as well. So, solving rational equations. Remember, you want to find the domain before solving rational equations if there's a variable in the denominator. To solve rational equations, the rational equation contains one or more rational expressions. To solve a rational equation, first multiply each side by the least common denominator of all the denominators. Be sure to exclude any solution that would produce a denominator of 0. That's what that's talking about. You have to check if there's any exclusions right off the bat. Now, this is back to our first unit. So I just made up an equation. You don't have to write this down. But if you remember, what did we do? We wanted to clear the F word, fractions. Okay, so we wanted to clear the fractions. So there was a way we cleared out the fractions, and we multiplied by the LCD. So this LCD for this particular equation, this is back again to an old type of problem, we would have multiplied through by 12. So we would have multiplied each piece by 12. And if we did that, 3 goes into 12 4 times, and you would have had 4 times x, plus 2 goes into 12 6 times 1. Over here, 12 goes into 12 once, you'd have x plus 2. And then we would subtract x, subtract 6, and we would have solved and got x is negative 4/3. Okay? This particular problem had no restrictions because there was no denominator with a variable. Today, we are going to be clearing the fractions, but now they're going to have more complicated denominators. So in this example, what is the LCD? So if you have 10, remember you need an LCD, you need all of the first denominator, 10. You need anything new in the second denominator, x plus 1. And then you need to check if the third denominator here has any factors of it that are other than what you've already written down. Is 5 a factor of any of these? Yes, it's a factor of 10. So this would be your LCD. So the LCD, they multiplied through and they did 10 times x plus 1 times each part of the whole entire thing. Now, the way they wrote it, I think you might not get what they're writing there, but I'm going to show you examples. If you went back to it, you might understand that when they multiplied the first fraction, the 10 would have canceled out, so they had to do 9 times what was left, x plus 1. When they multiplied the second fraction by all of that, the x plus 1 would have canceled. They had to do 2 times the 10. And over here, they multiplied by 10 times x plus 1. They divided 5 into 10 and got 2. And then multiplied the 2 times the 2. That's where that 4 came from. So they did a little bit differently. I might have shown you in an example. But once you get through with the result, you need to check. This particular situation, there was a 0 that you have to exclude from the domain because x plus 1 can't equal 0. So it would have been x can't equal negative 1. That would be your exclusion to the domain. So let's do an example of a problem. So number 1, we are going to check and look at the denominators and determine the LCD. You need all of the first denominator. So the LCD must contain 4 and x. You look at the second denominator. Does it have a 4 already? Well, I mean, do you already have a 4? Yes. The third one, do you already have an x? Yes. So that is your LCD. So to clear out the fractions, we want to multiply each term by 4 times x. Now, for the first problem we do here, I'm going to go ahead and show 4 times x times 1 over 4x minus 4 times x, 4x times 3 over 4 equals 7 over x times 4x, so that you can show your cancellations. 4x cancels with 4x, so all I'd have left is 1. On the second fraction, when you multiply 3/4 by 4x, the 4's would cancel out, giving you x times 3 or 3x. And on the right side, the x's would cancel out, and you would be left with 7 times 4, which is 28. Next, we would subtract 1 from both sides, giving us 27, and divide by -3, giving us -9. On number 2, this is much like or similar to the example I went over initially. The denominators are 5, 3, and 1, if you will, 1 over 1. 5 times 3 would be my LCD, so it's 15. So I need to multiply the entire equation by 15. I'm going to go ahead and show it in here. So I'm going to put the 15 there. I'm multiplying 15 times each piece. You can eliminate the parentheses if you wish. Maybe that would make it look less messy. 5 goes into 15 3 times. So I need to do 3 times 4n minus 3. Minus, don't forget to bring that sign. I can do 3 goes into 15 5 times. So I'm going to have to do minus 5 times 4 minus 2n. And on the right side, 1 times 15 would be 15. Now I need to do my distribution. So I'll have 12n minus 9 minus 20 plus 10n equals 15. I'm going to combine any like terms. I have 22n minus 29 equals 15. Next, I would add 29 to both sides, giving me 22n equals 44. Then I would divide both sides by 22, giving me n is 2. Now, I did not write any exclusions on either of these problems. You must check if your denominators have a variable. These did not, so we're all good with that problem, but I did need to tell what the restrictions probably were on the first one. What could x not be? Yeah, x can't equal 0. We didn't get 0, but it is excluded from the domain, so you always want to check that. Okay, number 3. First thing I'm going to do, I'm going to say, what can x not be? Well, since x plus 4 can't equal 0, x can't equal -4. And then I'm going to say, well, my LCD for this one is x plus 4. The denominator on a 10 is just 1. So I'm going to multiply each piece by x plus 4. I guess I don't have to put those parentheses, but anyway, what's going to happen on the first fraction, the x plus 4 will cancel out, giving us just 2. Same thing on the second one, and we'll get just 3. But on the right side, we're going to have 10 times the x plus 4. So we add 2 and 3 and get 5. Distribute to 10, or you could divide by it right now. 10x plus 40. Okay, and then I would subtract 40 and get -35 equals 10x, and then divide by 10 and get -3.5. Since that's not -4, we're good. Number 4 has a double star next to it. Maybe that's because it's not in the form. This doesn't look like these last two. Then there's another way you could solve it. What is another way that we could do this problem instead of finding the LCD and clearing the fractions? Solve it as you would a proportion. Because you have a ratio compared to a ratio, you could use the cross product property. Okay. Now, let's first, though, think about what x can't be. This is 2 times x minus 1. So since 2x minus 2 can't equal 0, 2x can't equal 2, x can't equal 1. And this one factors to x plus 1 times x minus 1, so we know x can't equal -1 either. Right? So now I'm going to go for my cross product property. I'm going to multiply 5 times x squared minus 1, which is 5x squared minus 5. Going in the other direction, I got to do 15 times 2x minus 2, which would be 30x minus 30. Next, I need to set this to 0, so I'm going to subtract 30x and add 30, which will give me 5x squared minus 30x plus 25 equals 0. I can see that all three of those terms are divisible by 5, so I'm going to factor out a 5. X squared minus 6x plus 5 equals 0. Now, because 5 has been factored out, you can actually divide both sides by 5, and you would be reduced down to just this equals 0. It does not affect the solution. And it's not part of the solutions because you can't set 5 to 0. It's not equal to 0, right? So if there was an x on it, that'd be a different story. So all we really need to worry about here is setting the factors of the trinomial factored equal to 0. So if I factor that, that's x minus 5 times x minus 1. And then I get set each factor to 0 that matters, and the 5 doesn't. So that gives us x is 5 and x is 1. But we determined in the beginning of the problem that x can't be 1. So therefore, one of the solutions is eliminated. It's extraneous. So the only solution that works is the 5. Good. Okay, number 5. We cannot do cross product property on this because it's 3 things. Okay, the denominator or LCD. Well, x can't equal -2 and x can't equal 0 either. So I know those 2 answers are no good. The LCD is going to be multiplied through by x times x plus 2 because you need all of the first denominator, and then what's new in the second, x plus 2 and x are different because these are married, the x and the 2. This is a different term or a different factor. So x times x plus 2, x times x plus 2, x times x plus 2. We're multiplying all 3 pieces by x times x plus 2. On the first one, I hope it's not bothering anybody that I'm doing this right on the problem, because hopefully you're doing something lightly that you can see we're canceling out your x plus 2. On the first fraction, x times 12 would be 12x. On the second fraction, when you multiply by the LCD, the x's would cancel out, and you'd have 3 times x plus 2. And on the right side, nothing cancels out. So I'll have 2x times x plus 2. Okay, is everybody okay with how I'm doing this so far? Because if you want, I can write more details down. Like I could rewrite this whole problem and write all this stuff next to it, and then I would show it somewhere else what I was canceling. Anybody want me to do that? I can do that on the next one if you like. Or if we're comfortable with what I'm showing you right now, I'll keep going this way. All right, we got to do some distribution. So let's see, we got 2x squared plus 4x on the right. I'm going to set this to 0. I have to, that's 15x, right? Put those together. I have to subtract 15x. I'm going to have minus 11x and then minus 6. I'm going to factor that. 2x times x. Factors, I have to do 6, and it has to be a minus 6 and a plus 1. Set those to 0. X is going to be -1/2, and the other one, x would equal +6. Neither of those are excluded from the domain, so those are both solutions to the problem. Okay. Number 6, you guys need to turn a page, I hear. Well, I have the notes too. What are we going to, first of all, let's determine our exclusions. Y can't equal, what would make the first denominator 0? -1, and the second one, 1. So y can equal -1 or 1. The LCD, we need the y plus 1, the 4, the denominator's just 1. We need the y minus 1. So our LCD, or what we need to multiply by, is y plus 1 times y minus 1. And don't forget the 4. Y plus 1 times y minus 1. And the third one, y plus 1 times y minus 1. I'm just going to write it 3 times there. And then I can show what I'm canceling, etc. The y plus 1s would cancel out on the first one. Oh dear. We're going to have y minus 1 times 3y minus 2 equals, this one's going to be a doozy. Okay, a little bit long. The second side, when I multiply 4 times the LCD, I just have to do that. 4 times y plus 1 times y minus 1. Minus, and keep a parenthesis, please. You need minus y plus 2 times, and what's going to be left here? The y minus 1 cancels with the y minus 1, and we have y plus 2 times y plus 1. Ooh, that's a long one. We got some foiling out to do, right? Bless you. Or double distribution. Y times 3y, 3y squared, y times minus 2, and -1 times 3y. So we have -2y minus 3y. So I got minus 5y. -1, -2 be plus 2. I multiply them. Okay, now I'm skipping a step on here. So this one, though, I'm going to write the 4 down. I'm going to multiply out y plus 1 and y minus 1, which would be y squared minus 1. Middle terms drop because they're a conjugate pair. Last, I'm going to keep that minus sign, and I'm going to keep a parenthesis now, and I'm going to distribute this out. Y squared plus y plus 2y would be plus 3y, and then 2 times 1 plus 2. All right, I got some simplifying to do. So I'm going to rewrite the left side, 3y squared minus 5y plus 2. I'm going to distribute on the right side and get 4y squared minus 4 minus y squared minus 3y minus 2. You got to ram that subtraction through. In other words, you're subtracting everything in the parentheses. All right, I got another simplification to do. 3y squared minus 5y plus 2. On the right side, I take 4y squared and subtract y squared from it. Gives me 3y squared. I got minus 3y, bless you. -4 minus 2 be minus 6. Okay, finally, we're getting closer. We got 3y squared on both sides, so let's just cross it off, because we're going to subtract 3y squared from both sides, which eliminates it. We have a positive, we have options. We can either add 3y to both sides or add 5y. I'm going to add 5y. And I'm also going to add 6 to both sides. So if I add 6 to both sides, I'll have 8 on the left. And if I add 5y to both sides, I'll have 2y on the right. And I'll finally divide by 2 and get my answer of 4. And let's hope we don't have to cross it out. Because we did all that work. We'd rather have an answer, right? I mean, what if one of the exclusions was 4? That'd be kind of a bummer, but it's not. Okay, so this is the solution. It happens, by the way. Sure could. Yes, ma'am. It just takes, and honestly, you need to write the steps like I did. You know what I mean? You have to take your time with it so you don't make any careless boo-boos. That's the only hard part about it, is that you might do a distribution wrong somewhere. You know, there's places to make little mistakes. I was asked if this could be a question on a test, and I said yes. I'm not going to put the worst ones on ever. There's not going to be a ton of this kind, or something where it came, was that much involvement. But they're definitely plausible. This guy over here, he factors to x plus 4 times x plus 2, which is probably making you happy because I can see it's not going to be maybe quite as bad a problem as the last one, because the other two factors over here are part of that, are factors of the right side. So I need to multiply through by x plus 2 times x plus 4. And I also need to realize that x can't equal a negative 2 and x can't equal a negative 4 in the end. All right, so I'm just going to write x plus 2 times x plus 4 times all of these pieces and start canceling. All right, x plus 2 will cancel out with the x plus 2. We'll have left 7 times x plus 4. Oh, I was missing a parenthesis there. Minus, I'm going to bring that 3 down, and then I'm going to cancel out the x plus 4 in my LCD that I'm multiplying by, and then I have left to multiply negative 3 times x plus 2. On the right side, the entire denominator goes away, leaving me with just 2. Okay. Now I need to distribute on the left. I get 7x plus 28 minus 3x minus 6 equals 2. All right, next we'd simplify. 4x plus 22 equals 2. Subtract 22, 4x is equal to negative 20, and then divide by 4, and we got negative 5. Right, next, number 8. Well, this one you're not going to like a whole lot either, because actually it has 3 pieces. Okay, this x squared minus 9 factors to x minus 3 times x plus 3. We all know that, right? But the second one, it factors to x minus 3 times x minus 3. I'll write them down here for you. So guess what? This is not enough LCD, because this one has 2x minus 3s. You have to have all of the first denominator and what's new or extra on the second. So I need another x minus 3. That's the LCD. Okay, so here's what we need to do. We have to multiply. Okay, can we just do this for a second? Can you just see if we can't shorten this up? And if you've got this written down, I'm just going to look at it each time. Let me see if this works for you. Your denominator here has an x minus 3 and an x plus 3 already. That would get rid of that part. So what would you need to multiply 4x by? Okay, 4x times x minus 3. Minus, you've got this x minus 1, so I'm going to bring it down. But I have to see what's new in the denominator. My LCD, this one has 2x minus 3s. Our LCD has the 2x minus 3s, but it also has an x plus 3. So we will need to multiply the x minus 1 by x plus 3. Okay, over here, the only thing this denominator has is the x plus 3. My LCD has 2x minus 3s in it, so we have to do 2 times x minus 3 times x minus 3. Okay, how was that? Was that okay? Did anybody get confused by me doing it that way, where I didn't show what I crossed out? All right, so what happens, you know that if you're multiplying each part of the equation by the LCD, the denominators are going to be gone. All right, let's distribute. So 4x times x would be 4x squared. I'd have minus 12x. Now, before you do something with that minus sign, don't just write it down. And then make a parenthesis, and then multiply this out. That was what I think you should do every time, instead of trying to do the distribution of a minus sign at the same time. That would be a real easy way to make a mistake. So x times x, x squared. X times 3 got positive 3x minus 1x will be positive 2x. We've been foiling all year. We had to be able to do that. Negative 1 times 3 minus 3. Okay, on the right side, I'm going to have to do 2 times the product of x minus 3 and x minus 3, which is x squared minus 6x plus 9. Okay, we got some simplifying to do. Okay, so I'm going to first distribute my subtraction sign through all the terms in the parentheses on the left. So that'd be minus x squared minus 2x plus 3. And on the right, distribute the 2. 2x squared minus 12x plus 18. Okay, I still have simplifying to do on the left. So I'm going to simplify this to 3x squared minus 14x plus 3. I'm rewriting the right side, and yes, I would advise doing that. Don't jump steps. Okay, subtract 2x from both sides. Add 12x to both sides. Subtract 18. And now I'm down to a very doable factoring. This is x minus 5 times x plus 3. That gives me a solution of 5 and negative 3. And then you say, well, geez, I forgot all about where I started from because this took so long. Well, go back to the beginning. Were there any restrictions on our variable that we didn't look at? Yep. What can x not be? It can't be 3 and it can't be negative 3. I heard you. All right, so we got to cross that answer off, and the only solution is 5. Okay, now we're going to have a little fun with word problems. Here it comes, the word problems. You've been looking ahead at all. You've been saying, wait, where'd that mixture problem come? Where's this? What's that about? Well, we're going to get there. All right, this one I'm going to break down in a chart. Let me ask you a question. Do you remember anything at all about how you calculate how far you went? Like there was a little formula for distance is equal to something. What do you do with it? What are we pointing at? Oh, no, the distance formula. Yeah, I got the distance formula up there. No, I'm not talking about that. If you were driving, how would you calculate how far you went? How fast you were going times how long you were going. Okay, distance equals rate times time. Sorry, I led you the wrong way a little bit. I think it's all right. It's just you were thinking geometry and didn't really remember. Sorry, I guess if we read the problem, we might have thought of it faster. All right, distance is rate times time. And you got a river with a current. Their current is 6 miles per hour. That's important. In her motorboat, Marissa can travel 12 miles upstream or 16 miles downstream in the same amount of time. Those are my clues. What is the speed of her motorboat in still water? I'm going to let that be R. What's the rate or speed of her boat in still water? Now, distance is equal to rate times time. So I'm going to make a little chart. Now, there were 2 scenarios here. One was her going upstream, and one was going downstream. So I need an upstream and a downstream. And what did they say was the same? So that's in time. So I'm going to put an equal sign right here because I think I'm going to get an equation out of that. I want this thing solved for time. Well, let's see what else it says. The current is 6 miles an hour. She gets to travel 12 miles upstream. So where can I put that? 12, you're going how far? That's your distance, right? So that would go in upstream. So that's here, 12. And 16 miles downstream. So I'll put the 16 under D there. Those are D's. Those are distances. All right. I got something happening with the current, and it's in miles per hour. What does that affect? Okay, why does that matter? Okay, so if you've got a current, what's it going to do? What's it affecting in the DRT? The rate. Okay, it's affecting the rate. The rate you're speeding going at is miles per hour, so it's having an effect on this. Okay, we're going to use R because we want to figure out the still water speed. What will the current do to you when you're going upstream? It's going to slow you down. So it's going to be R minus 6. And if you're going downstream, what would it do to you? Yeah, so it's going to be R plus 6. I'm trying to make this thing make sense to you, okay? So now I need to fill in time, but my formula says distance equals rate times time. Well, here's why we learn to manipulate formulas. If you were doing a computer program, you would be putting in something for t. You'd say t equals. What would it equal? Solve for t. Distance divided by rate. Okay? So I take my 12 divided by my R minus 6. I take my 16 divided by my R plus 6. And I was told that it takes the same amount of time to do this. So my times are equal. So now I set those equal to one another. 12 over R minus 6 equals 16 over R plus 6. Now I do my cross products property. I'm going to do 16 times R minus 6 first, just because I feel like it. And that gives me my 16R on the left. Minus, that'd be 96. And then 12 times my R plus 6 will give me 12R plus 72. And now I've got smooth sailing. I'm going to subtract 12R. I'm going to add 96. And divide by 4. So the rate in still water is 42 miles per hour. Okay, we're going to set up mixture problems like this too. I quite frankly don't like, these are rational expressions, aren't they? That's why it's in this chapter. But I'm not real, the book doesn't teach it, or it doesn't show the examples quite the same as I'm doing it with the chart. Okay. It's similar, but not exactly the same. I might do some problems a little different. Now, these are called work problems. This next one, Adam, Bethany, and Carlos, this is called a work problem. Work together. Work together. Adam, Bethany, and Carlos own a painting company. To paint a particular house alone, Adam estimates that it would take him 4 days. Bethany estimates 5.5 days, and Carlos says it'll take him 6 if he worked by himself. If these estimates are accurate, how long should it take the 3 of them to paint the house if they work together? All right, now, if they work together, they're trying to just do one job. I have actually 2 ways I could do these problems, but they always come out the same. So I'm going to do it sort of like the book says it, and you're going to do one entire job. Okay, so in 1 day, what can they do? You know, like we're going to find out how long it's going to take them to all together do this one job. How much of the job can Adam do? If it takes him 4 days, then he can do 1/4 of that job. Okay, so the time he's going to take, he would be 1/4 of the time that it takes for all of them together. Okay? If Bethany takes 5.5 days alone, then she's going to take 1/5.5 of the time that it takes for them to work together. So she's going to be time over 5.5. And then Carlos, it took him 6 days, it's being 1/6 of the time. Okay, now, stop doing that. Scott, I know you're not, and I've seen it happening. Just ignore it. It's not that fascinating. Okay, so LCD. Now, I can do a lowest common denominator for you, or we can just go ahead and multiply these numbers. Do you care? Okay, so that will not affect your outcome. So you can go ahead and just multiply them together, which would be 132, I think. All right, there is a smaller amount because factors of 2 are both from 4 and 6. So actually 4 times 3 would be 12 times 5.5 would be the lowest common denominator. Okay, so let's just do the 132 because it doesn't hurt anything. All right, so we're going to multiply through by 132. It's not the lowest, so I'll preface that. I don't want somebody thinking I don't know that there's a lower one. All right, so please, what's 132 divided by 4? 33? Thanks, 33t. Now we got to figure out what 132 divided by 5.5 is. 24? Oh, imagine that. It's 4 times 6. Plus, what is 132 divided by 6? It should be 22. It's actually easier to do with that number and do it in your head than if you didn't. Okay, so I got 132 equals, and I got to add these terms. That's 57, 67, 77, 79 t divide by 79. I don't know why I'm writing this. You guys know what I'm saying. It's 1.7. It's going to take 1.7 days for them to do it together. Is that reasonable? Why not? All 3 of them are painting. Cut the time way down. Okay, Carlos and his friends rent a car. They split the $200 rental fee evenly. I don't know how many friends he has. We got to see. Carlos together with, I don't know how to split it up right now, because that's what my point was. Carlos together with just 2 of his friends decide to rent a portable DVD player as well and split the $30 rental fee for the DVD player evenly among themselves. Okay, wait a minute. So if they're going to split that up, how many of them are there? So Carlos together with just 2 of his friends are going to do the $30. 30 divided by 3 is going to give it $10 each, right? Okay, so I'm going to note that. Carlos ends up spending $50 for these rentals. Write an equation using n for this number of friends he has and solve the equation for n. I know it sounds funny. Okay, now Carlos and his friends are going to split that rental fee. So 200 divided by n. Wait a minute. But wait a minute. N is the number of friends Carlos has. Doesn't Carlos have to pay 2? So what is this? This isn't 200 divided by n. It's n plus Carlos is n plus 1. Okay, do you follow me? All right, now in the second fraction, we took 30 and we divided it by 3 because it said Carlos plus 2 of his friends. That would be 3 people. And then this is about what Carlos has to pay. Carlos has to pay himself plus his friends divided into the 200. He's got to pay that part. Plus he's got to pay part of the 30 divided by 3, which was $10. And that's going to equal, how much money did he spend? Yeah, 50. All right, so now we got a rational equation. We can just simplify this to 10, of course, and then we won't have to do anything but multiply everything by n plus 1. Oops, that is n plus 1. Okay, so the n plus 1 cancels. We get 200 plus 10 times n plus 1 equals 50 times n plus 1. And don't forget to distribute. Let's go see how many friends Carlos has. We're going to distribute. Maybe he looks pretty young there. 50n plus 50. 210 plus 10n. Okay, we could probably have skipped a step there, but subtract 10n, subtract 50, that's 160 equals 40n. And then we divide by 40, and Carlos has 4 friends. What? That's not bad. Most people only have one good one. And those change over time. All right, I have the book worksheet for you. Let me pass that out.